Hey, this is Mr. Ayton, and this is 8th grade class corner, and we're going to be doing photosynthesis stage 2. We've already been through a photosynthesis introduction. We've already been through stage 1, which was the light-dependent reactions, and now we're going to be zeroing in on the light-independent reactions. So let's get to it. If you remember what happened in stage 1 happened when we had 6 water molecules, and we had light energy, and the light energy was going into breaking those water's bonds, and what did we end up getting? We got 6 moles of O2 gas coming out of it. All right, and so we also got some high energy electrons, didn't we? And some ATP and some NADPH. And so what happens in stage 2? Well, stage 2 takes 6 moles of carbon dioxide and it makes some glucose, C6H12O6. And so what do we have happening here in stage 2? We have carbon dioxide coming in. Obviously, this is all happening in the stroma. And what is breaking the bonds of the carbon dioxide? How does this get the reaction going if we don't need light? If it's light independent, well, we have ATP and NADPH coming from stage 1. Okay, and that's breaking the bonds. Obviously, the ATP is becoming ADP, the NADPH is becoming NADP plus, and that's going back to stage 1. And what are we getting is C6H12O6, which is otherwise known as glucose. Okay. So let's take a look at more in depth of this stage 2, which is the light independent reactions, and we call this the Calvin cycle. And so what happens in the Calvin cycle initially is we have carbon dioxide gas added. However, that's a big misconception because it's a cycle, which means there's really no start, there's really no end. I'll talk about that in just a second. So we have carbon dioxide coming in here, and when the carbon dioxide comes in, we have a 5 carbon molecule right here. 1, 2, 3, 4, 5 carbon molecule coming in here. And so if we have 5 carbon molecule and we have 1 carbon, well, guess what? It's added to a 5 carbon molecule. And so what happens here is that becomes 6 carbons, right? 1, 2, 3, 4, 5, 6. It becomes a 6 carbon molecule. Obviously, we have 5 carbons and 1 carbon. That makes 6 carbons. Well, guess what happens is we have the energy is coming in from 6 ATP molecules and 6 NADPH molecules. So what do I have here? I have energy coming in. I'm going to have this energy coming in here as this orange type arrow. This energy is coming in. It's breaking the bonds. So I have ATP coming in. I have NADPH coming in, and these are coming in from stage 1, and it's used to break the bonds, doesn't it? Because we need energy to break the bonds. And so this 6 carbon molecule now becomes 2 3 carbon molecules. Okay, this system is designed. Okay, this is a design system of what's happening. It just does not happen by random, does not happen by chance. And what does the ATP become? It becomes ADP. What does the NADPH become? It becomes NADP plus. And where does that go back to? Is stage 1. Stage 1. Well, guess what? 2 of these 3 carbon molecules leave. Now, how does that leave? Well, it just keeps going. Okay, keeps going in the cycle. But 2 of the 3 carbon molecules make a 6 carbon sugar molecule. And what is that 6 carbon sugar molecule known as? Is glucose. And so that shoots out C6H12O6, which is our energy source as well as every plant's energy source as well. So think about that. This cycle is making its own energy. Plants make their own energy, and it makes all the energy for us in this high energy molecule called glucose. Now, for every 5 3 carbon molecules that stay in the cycle to form into a 3 5 carbon molecule, okay, and absorb the energy from 3 ATP molecules. And of course, what does that ATP molecule become? Becomes ADP. So these 3 end up using energy. Of course, there's more energy coming in here from ATP, and 3 ATP molecules are coming in here. And what do you know it's becoming? It's becoming your 5 carbon molecules. Okay, and you'll see how the math all works out. Everything's balanced, which is so cool. And so what do we have here? We have 6 carbon dioxides coming in. Okay, now of course, what did I have over here is 6 5 carbon molecules. So you see 6 5 carbon molecules, that's 30, and 6 carbon dioxides, that's 6 carbons. It makes 36, which means 6 times 6 equals 36. Everything is conserved. Everything is conserved. And what do I have coming in here? I have ATP coming in. I have NADPH coming in. It's breaking those bonds, and it's making 12 3 carbon molecules. Everything is conserved here. Now what happens to the ATP? Well, that becomes ADP coming out, goes back to stage 1. What happens to the NADPH? It becomes NADP plus, that goes back to stage 1. Now what happens with 12 3 and 12 3 carbon molecules? Well, sometimes, bam, we have glucose coming out. And 10 3 carbon molecules keep in the cycle. And what happens to the energy that's coming in of the ATP? Well, it rearranges, it breaks bonds, and then it forms some bonds, and it creates, we go from 10 3 carbon molecules, that's 30, 10 times 3, and we have 6 5 carbon molecules, that's 30, 6 times 5. And what happens to the ATP? It becomes ADP. Now, I want you to see, in a cycle, there is no starting point. There is no ending point. If you ask a Darwinian evolutionist, where's the starting point of the Calvin cycle, they'll say carbon dioxide. And I've said before to them, well, don't you need the 6 5 carbon molecules before? And they said, well, yeah, well, that's a starting point. Well, don't you need this? Don't you need energy? Yeah, you can see. There's no starting point, there's no ending point. We kind of have to have like a starting point in order to begin this, but remember, this starting point already needs something before it. So because in every single cycle, cycles don't begin. Cycles don't evolve. This is a breakdown of Darwinian evolution right here. This is the killer for Darwinian evolution, is any single cycle. And the Calvin cycle is one of the main hits of Darwinian evolution. They cannot explain how this evolved. There is no explanation for it. It is only by divine creation, by a creator. And remember, guys, this is pretty complex for high school right here. And you guys are in middle school. This isn't even close to the complexity of the Calvin cycle. The complexity of the Calvin cycle, in terms of biology, in terms of chemistry, in terms of physics, in terms of every which way, the Calvin cycle is insanely complicated, more complicated than we ever could understand. And that is because we have an amazing creator in God, in Jesus, who holds all things together. So guys, this is 8th grade class corner, photosynthesis stage 2, light independent reactions. Make sure you do your self-assessment and make sure you praise God for an amazing process called the Calvin cycle. Thanks, guys. I'll talk to you soon. Bye.